uh, the aluminiothermy, we discuss the thermite reactions. Okay. In today's class, we're going to discuss the electrolytic reductions. Okay. Electrolytic reductions, for example, what we are studying here, the removal of, like for example, from the starting, if I started, that we purify the ores, and after having the ores purified, the impurities are being removed, the sand, soil, whatever it is, we remove it. Then we have four types of ore. We have sulfide ore, we have carbonate ore, we have oxide ore, and we have halides ore, like NaCl, like KCl. Okay, means fluorine or chlorine groups are added. This is called halogen group. Okay, oxygen is Al2O3, oxidation it is oxide ore, Fe2O3. Carbonate ore is like CaCO3, carbonate ore is in carbon. In sulfide ores like PBS, lead sulfide, or you can say that it is HGS. Okay. Now, what we does here is that we remove the we first convert these two ores, sulfide ores and carbonate ore, into their oxide forms, like PBS by roasting. It get converted into PBS plus sulfur dioxide. Similarly, carbonate ore CaCO3, when you heat it in the absence of air at 900 degrees Celsius, it will get converted into CO plus CO. Why we are converting it? Because it is easily reducible. Because lead oxide can be easily removed, means oxygen can be removed from it. Okay, and like calcium also, you can easily remove the oxygen from calcium, and then you can get the pure calcium metal without oxygen. So an oxide form is already in oxide forms. These are the halide forms, halide ores, which are found in the highly reactive metals. Generally, highly reactive metal forms halide ore, or highly reactive metals are found in the form of halide ore. Okay. Now what we are doing here is that, like for example, you have calcium. Just like for example, we have sodium, potassium, calcium, magnesium, aluminum. These metals comes under the category of highly reactive metals. And they, if like for example, if sodium is found in the form of sodium chloride, potassium is found in the form of potassium chloride, calcium is in the form of calcium oxide. Initially, it formed in the form of calcium carbonate, but we convert it into calcium oxide. Then magnesium is found in the form of magnesium oxide. Okay. Or aluminum is found in the form of Al2O. So these metals are found in their oxide form, and we want to get metal, pure metal from. We want to convert it into Na. We want to get potassium. We want to get calcium. We want to get magnesium. We want to get aluminum. So we did electrolytic refining, sorry, electrolytic reduction. We did electrolytic reduction. Okay. What we does? We does electrolytic reduction. And how we does, and for other metals like this one, which are below aluminum, we do different method, like reduction with carbon, simple roasting. With that, we studied in the previous classes. Now, what we does in the electrolytic reduction again, in the electrolytic reduction, we took the molten metal ore, or if it is in oxide form, whether it is, yeah, like for example, if you are just going to take aluminium or sodium chloride, you will take the sodium chloride in the liquid form, molten. Why in the molten? Because if you take in the aqueous form, then it will gives you chloralkali process. Okay, then like suppose this is anode, and this one is cathode. When you pass electricity to it, what is going to happen? This Na will receive, this is Na positive, and Na positive can be converted. Na positive means that it has 2,8 electron configuration. It has loosened one of its electron. And if you want to get Na solid, so it must be 281. Coming number 281 11 with one electron. With means with all 11 electrons. Now it has 10. Now it needs 11 electron to become Na solid. So we need to add one electron to it so that it will become Na solid. So what happened here is that this Na will goes to the negatively charged rod where it will receive the one electron. Okay, and will get converted into solids. This is going to happen at cathode. What is going to happen at anode? Anode means anode is positively charged. So what will happen? We have two chloride atoms. That's two chloride ions will reach there. Because chloride ion is 288 electronic configuration. What is the difference between chloride ion and chlorine atom? Chlorine atom is 287 electronic configuration. So it's chlorine atom. So to become a chloride ion to chlorine atom, it must lose one of its electron. So when it lose one of its electron, it will become chlorine atom. But chlorine atom cannot exist independently. It is an unstable state for chlorine atom. So what it will does? It will combine with the another chlorine atoms and form chlorine gas. 7 electron of this, they will form chlorine gas. And this. You will get Cl2. So the two chloride ions, so the two chloride ion will go at anode. The two chloride ion will go. They will lose one electron each and form chlorine gas, Cl2 gas. By losing one electron each, in total they will lose 2 electrons. The two chloride ion will lose 2 electrons. So here overall reaction, if I'm talking here is overall reaction is 2Na solid. It gives you 2Na plus Cl. Got it? Yes or no? Got it?
Why did we do this whole process though?
Why did we do?
The whole process though.
Why did we? Because we need to separate the sodium and chloride atom. For this, we melted it, and this can be done by electrolytic reductions. Reductions. We do the because they are tightly bonded, because they are highly reactive metals. They have a strong electrostatic force. The highly reactive metals are bonded together with a strong electrostatic force. So we cannot get the metals. We need to change the ions. For example, sodium ion will get converted into sodium solid. Like in the previous cases, what we are doing. Actually, when we are converting ions into its solid form, we need to transfer the electrons. And transfers of electrons for highly reactive metal is only possible by electricity, by using cathode and electrolytes. That's why for highly reactive metals, we use electrolytic reductions. Okay. So what we does here is that in this method, we don't write this one. Don't write this one. In this method, okay, in this method, molten NaCl is taken in the electrolytic cell. We take the molten NaCl. And when electricity is passed, the metal ion get reduced. Metal ions, addition of electron is called reduction. So we use reduce. Because sodium metals or any of the metals will get electrons. So receiving of electron is reduction. So we use the word reduce for this. Two metals solid at cathode. Okay, they will get reduced to metal solid at cathode. Understood? Because reduction always take place at cathode and oxidation take place at anode. Now what is going to happen here is that further, for example, if we took the example, in case of reduction of sodium chloride, we're taking the example of sodium chloride. Molten NaCl is taken. We take the molten NaCl in the electrolytic cell, and by high current is passed, and we pass high electric current. Then at cathode, the sodium ions are reduced. Sodium ions are getting reduced. If they are added with electrons, the two sodium ions will receive one electron each and will form two sodium solid. While at cathode, the two chloride ions are oxidized. Oxidized means removal of electrons to form chlorine gas. Means the two electrons, one each. The chloride ion with 8 electrons, 288. When they lose one electron each, they will form chlorine gas. So they will become chlorine atom now. By losing one electron, they become chlorine atom. And chlorine atom never exist independently. They make bond with another chlorine atoms. And they form chlorine gas, Cl2. The chlorine gas is found at NO. Overall reaction. Okay. So start writing. From here. Start writing from.
Sir, we have written this.
I think Zainab was absent so let me write.
We have written this. Yeah.
You have written this one?
Yes.
Okay. Vedant, you also? Vedant, are you there?
Yes.
So have you written this one? Yes or no?
No, I'm writing.
What a term first. Done? Vedant noted?
Yes,
Yes or
done.
no? Note this one also first. Ayan Abdul Kavi and Vedant, please turn on the camera. Yes, noted everyone.
Yes, done.
So similarly, we do the same for the aluminium also. we took the aluminium metals, aluminium oxide also as molten in the molten form, and then we pass
Louder.
when we pass electricity, then we get uh, oxygen atoms and we get the okay, and means we are just balancing. We write the balancing chemical equation. That's why we are writing it. Let the six oxide ion will go. Okay, six oxide ion will go, and they will form three oxygen atoms. Three oxygen atoms. Because one oxygen molecule has two oxygen atoms. So this is, and they will lose to three, six to that one. They will lose 12 electrons to become um, three oxygen molecule. And similarly, this 12 ions will be because four aluminium get three aluminium, three electrons. So they will get this one. It is not so important. Okay, let's move further. Yes, why not? I will see it a little bit louder. Let's move further. Now, moving to the next part is electrolytic refining. That is a very, very important part of this chapter. Is just electrolytic refining contains 70% weightage of the total chapter. Means most of the questions are going to come from this portion. So what is electrolytic refining? Let me explain what is electrolytic refining. Electrolytic refining is a process in which we purify the metals. Now, by different methods, like by using reduction with carbon, reduction with aluminium, or electrolytic reduction, we remove the oxygen or the halide atoms from the metals. Like for example, calcium oxide is there, so we get the pure calcium metal. There is aluminium oxide, we get the pure aluminium. If there is copper oxide, then we get the pure copper. But still, the metal that is obtained, it don't have any impurities. We can say that sand is not there, but it can have different kinds of atom in it. Like for the strip of copper can have the atoms of gold, platinum inside it. Okay, so it is possible. So what we need to do is we need to atom wise, we have to purify it. We have to check whether there is some I mean, like for example, if I'm just going to refine the copper. So refining of copper means that we need to check whether there is all copper atoms there or not. And electrolytic refining is the purest. Means by the electrolytic refining, you get the highest means pure metal. It's 99.99% you will get the highest means the purity of high. This we can simply say that the metal that is obtained by electrolytic refining is the of highest purity. Is of highest purity. We get the means it is not possible that means other methods. There are some other methods also like zone refining, other methods that we are going to study in the higher classes. But in the electrolytic refining, we got the highest metals or the highest purity metal. Okay. So let's study that one by one that what happens in the electrolytic refining. Like for example, if you are just going to, for example, you are just going to purify the copper. If you are going to purify the copper, concentrate here. I'm just telling you again that you have studied only 30% of the metals and non-metal can get. 70% of the questions are going to come from this portion only. So we made the two electron. In the electrolytic reduction that we have studied, we took the molten NaCl, but here we took the aqueous form. Okay. And we take the electrodes that we are just going to refine it. Okay, like for example, if I'm having then electrode that we need to purify the copper metal. Let's suppose, for example, we are just going to purify the copper metals. So we will take impure metal, impure metal rod, especially of copper, because we are just studying the example of copper. Add anode. We'll take at anode. And pure metal rod. Add cathode. We'll take pure metal rod at. And this is simple. Positive. Okay, this is positively charged, this is negatively charged. So pure metal rod, for example, you are just going to refine copper. So you will take a thin strip of copper, pure copper metal, and place it at anode. So you have to connect it with a negatively charged wire. And the rod which you are going to purify, you have to connect it with the positive terminal of the battery. And if you are just purifying, let's suppose if you are just going to purify copper, then you will take copper sulfate as the electrolyte. Copper sulfate. So when it is in the aqueous form, it will become copper sulfate, Cu2 positive, NSO4 minus 2. 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 Positive, CO4 minus 2. So when you take this electrolyte into it and you add some dilute hydrochloric acid also, dilute H2SO4 to increase the conductivity. To increase the conductivity. First of all, the question comes that, like in the electrolytic reduction that we studied, we took the molten metals. Okay. First of all, here, this is very important, just understand that electrolytic reduction is done for the highly reactive metals. But electrolytic refining is done for low reactive metals or the mid reactive metals, not for the highly reactive metals. Refining is opposite. If reduction is done for the highly reactive metals, the refining is done for the mid reactive metals. Why? Let's suppose, imagine that you are having a sodium electrode inside it in an aqueous solution of sodium sulfate. It will instantly react with the water molecule and will produce hydrogen gas and will burst. So it is so reactive, means in sodium, potassium, calcium, they are so reactive that they instantly react with water. So we cannot refine those highly reactive metals with this method. We can purify only the mid reactive metals. Okay, we can purify only the mid reactive metals. Understood? Yes or no?
Yes.
Yes.
So what is going to happen here is that this is copper ion. Let's suppose this is copper atoms. When we pass the electricity to this, what is going to happen? Just imagine what is going to happen. If this is negatively charged rod, so it will attract the positively charged copper ion. Okay. So what is going to happen is that this is copper ion at cathode. What is going to happen? This copper ion will receive the 2 electron from the cathode, because cathode is electron donator, and will convert it into copper solid. Everyone, please turn on your camera. Yes, you Faidan and Abdul Kavi, beta camera on karo. Okay, so this one is copper solid. What is the difference between copper ion and copper solid? Copper solid is a solid particle which is brown in color. This is a copper atom. And copper ion is blue in color. It is an aqueous solution form of copper. So when copper receives its 2 electron, it will get converted into copper atoms. And let's suppose this copper atom get deposited here in the form of brown. Let's take the brown copper. Okay, and it is getting deposited here. So one copper atom from this one get converted into copper. Another copper ion also get converted into this one. That this one is also get converted to copper solid. And this one is also converted into copper solid, and it start depositing on the surface of this one. Just imagine if all the copper atoms from this copper sulfate solution, all the copper ion from this copper sulfate solution, if they keep on depositing, then what would happen? You will see that the copper ion, the solution will become negatively charged. If you remove all the copper ion from it, what would happen? What would happen?
The solution will be negatively charged.
There will be more concentration of sulfate ion, and solution will become negatively charged. And it is not practically possible that you cannot have an electrolyte negatively charged. We need both, positive and negative both. We need both, positive as well as negative. Okay, understood? So we need both. So what is going to happen here is that we have Cu2 positive at cathode, it goes and converted into copper solid. So what happens is that in order to neutralize the atom or neutralize the electrolytic solution, there are many copper atoms here. There are many copper atoms here, Cu atoms. Along with it have silver atoms also, platinum atoms also, gold atoms also, but most of them are copper atoms. And as you know, the electrochemical series or the series is based on the reactivity series is based on the basis that which atom will donate the electron first. Like sodium is placed at the top because sodium can easily donate the electron rather than the other elements. सोडियम सबसे पहले इलेक्ट्रॉन डोनेट करता है दूसरे एलिमेंट्स के कंपैरिजन में, इसलिए सोडियम को सबसे टॉप पर रखा गया है. Similarly, magnesium, then after then we find that copper is after copper we have silver, gold and platinum. Okay, so in order to maintain the electricity, the silver atom will not donate the electron first and will not convert it into the ion. Copper atom will donate the electron because it is at the top of the reactivity stage. So in terms of donation, copper will donate the electron first. So if this is copper atom here in this one, it will convert it into copper ions. And these two electrons that are loosened by it, it will goes into the wire. It will goes into the wire, two electrons, and through the battery, it will reach through the battery. It will reach at cathode. And then again, this cathode will give this electron to this copper ion, and then again it will get converted into solid. फिर से next atom copper का, the next atom from this electron will get converted into copper ion by losing two electrons. और जैसे ही लूज करेगा वो दो इलेक्ट्रॉन इस वायर में होकर के एकदम से कॉपर में जाएंगे, यहाँ पर जाएंगे, और यहाँ से कोई भी एक कॉपर आयन वापस से दो इलेक्ट्रॉन लेगा. इट विल टेक द टू इलेक्ट्रॉन्स एंड विल कन्वर्ट इनटू कॉपर. एंड दिस प्रोसेस रिमेन कंटिन्यू. ऐसे बारी बारी करके सारे कॉपर एटम्स जो है वो इस इलेक्ट्रोड पर आना शुरू हो जाएंगे. दे विल स्टार्ट कमिंग ऑन दिस एंड दिस विल बिकम थिकर. आप देखोगे एंड ये इलेक्ट्रोड बहुत ज्यादा मोटी हो जाएगी और यहाँ से जो एक कैथोड थी सॉरी एनोड थी वो नीचे पूरी पूरी डिसइंटीग्रेट गायब हो जाएगी क्योंकि इसके सारे एटम्स यहाँ पर आ गए. ऑल एटम्स आर बीइंग ट्रांसफर्ड हियर. So most of the atoms are being transferred here, so it become thicker, and this will become what is going to happen here then? There is a deposition of anode mud which is carrying the platinum atom, silver atom, gold atoms which are not transferred. Okay, so these are the atoms of copper. This is called anode mud. Okay. So what happens again? Let me explain you in short. What is happening in the electrolytic cell? We took a pure metal rod at cathode and an impure metal rod at anode. And the same metal salt, like if you are refining the copper, then we'll take copper sulfate. If you are refining the silver, then we take silver nitrate, not silver sulfate. If you are refining the zinc, we take the zinc sulfate. So we take the same metal salt. Okay, same metal salt as an electrolyte. When we pass the electricity, then at cathode, the Cu2 positive ion will get reduced. Reduce means addition of electron to copper solid. Means when they receive two electron, the copper ion receive the two electron at cathode, they will get converted into copper solid. Okay. Then in order to maintain the electrical neutrality, of the electrolyte, the same amount of copper atom, the same amount of copper atoms are converted or we use, because at anode oxidation take place always, are oxidized. The same amount of copper atom we know are converted into copper ions by losing two electrons. And the copper ion will always goes into the electrolyte. It will not remain in the electron. And this process remains continued. One by one, the copper ion from this electrolyte, from copper sulfate electrolyte, will get converted into copper solid, and the same amount of copper atom will come into the electrolyte. And this process remains continued. One by one, a atom from this one, from this impure anode will goes to the cathode, and at last we'll have some impurities, which we call it anode. Understood? Yes or no? So here we have, so first you will make this one. First you make this one, the both the diagrams of this diagrams, and then we'll write the note over it. Both the diagrams after disintegration also. Write down topic electrolytic refining. Done? Made? Done? Done?
Done, sir.
Let's start writing. If you are getting stuck anywhere, then please let me know. Okay. Note it down fast. Done?
No.
Note it down first.
One.
Done? Noted? Noted up to here,
Yes.
yes or no?
Yes.
Okay.
Yes, sir.
Then write down the next part. And this process remain continued. At the end, we get pure copper at the cathode, and impure anode. While impure anode rod of copper disintegrate, leaving, this is LEAVING, leaving. This is leaving. Spell the spelling, leaving. Behind the impurities called enotment. Done? Done, everyone?
Yes.
Yeah.
Oh. So start writing this question.
The 29th one?
Yeah, no, not 29. Just start. Yes, which is the correct one here. Which is the correct one? A, B, C, D.
C.
Why A is incorrect?
The signs are incorrect.
Okay, why B is incorrect?
B, it says cathode over here and anode over here.
No, it's okay. If you are placing anode over here, cathode over here, and the
Oh.
movement of particle is also from anode to cathode. But the incorrect one is this one, that the anode node should be below the anode, not below the cathode. Okay,
Hmm.
and this one is correct. And why this one is incorrect? D.
That is incorrect because the Cu is not coming from anode, it's going to the anode.
Okay, very good. Yes, what you will do in this one? Question number 38. That pure metal is used as a anode and so which metal? So where you use, what you use at anode? At anode means you will you use pure metal or impure metal?
Impure.
Impure metal.
And at cathode,
Pure.
pure metal.
Pure silver.
Suggest a suitable electrolyte if you are just refining the silver metal. It is silver metal.
Silver
So
nitrate.
silver. And in the electrolytic cells, where do you get the pure silver? Pure silver.
At cathode.
At then the next one is okay. If we are just talking about the electrolytic refining of copper, okay, during the electrolytic refining of copper. So can you able to explain the whole process that first we will do, given are the steps for the extraction of copper from its ores. Write down all the step here. First we will crush the ore. It is copper sulfide. We'll crush it and we will enrich it by removing its impurities. Then we will roast it. Roasting of copper. What we does in the roasting of copper? Tell me. You know that in case of copper, Cu2s, why we are doing roasting? Because we need to obtain copper metal, copper sulfide to copper oxide form. Sulfide ore should be converted into clear oxide form. So we converted Cu to S and then we pass oxygen and we get Cu2O plus SO2. And then further this Cu2S and then Cu2O. Here the crushed ore itself behave as a reducing element. I have taught you previously also. Crushed ore itself behave as reducing element. Behave as reducing element. So we'll get pure copper and then sulfur dioxide. So if we don't need copper, we don't need oxygen, we don't need carbon and other metals for the reduction of copper oxide to get copper. The crushed ore in the container behave as a reducing. Then reduction of copper oxide with copper sulfide, we'll do this one. This is the second step. First, we will do the roasting. It will get converted into copper oxide. Then we again do the reduction. With crushed ore, this is the copper sulfide. This is the second step. Okay, reduction of copper oxide with copper sulfide. Okay, then we do the electrolytic refining that we have written. And then will you be able to draw the neat and level diagram for this one? That we have done in the notebook. Okay, next. Okay, question number 23 and 24. What should be the answer for question number 23 and 24? Help me fast. Option B.
For
Option.
with one, right?
Electrolytic cell consists of yes.
Cathode. Wait, never mind.
Positively charged anode, negatively charged cathode. So third and fourth. B. This one 24. Option A. Option A. Zinc will be deposited at cathode. Good. Okay. When we are doing the electrolytic reduction of molten chloride, so which metal is obtained when we are doing the electrolytic reduction of molten chloride? Which metal will you obtain? Chloride, first of all, it is saying electrolysis of molten chloride. So it means it is not the refining because we don't have the metal in molten form in the refining. It is electrolytic reduction. Electrolytic reduction is done for highly reactive metals. Now tell me the answer.
Option D.
Sodium and calcium. Okay, but not iron and copper. Because iron and copper are low reactive metals. Got it? Got it?
Yes, sir.
So first and second. Okay. Yes. Then number 12. It's correct. Question number 12.
Which question?
Question number 12.
Gold and copper.